Thanks very much for picking up another Making Saturdays Awesome video. We're going to be making a Brushbot this week. Once you're done making it, make sure to keep it around. We're going to be using it next week as well, but feel free to modify it, add things to it, change the design, whatever it is that you'd like to do. It's yours, so please do. That's what is interesting about this entire project. The whole Making Saturdays Awesome program, as well as ethos, is about empowering you to do what it is that you want to do, making cool stuff that you like. But you're gonna need a Brushbot next week. Luckily, we're gonna build one of those today. Our supplies are laid out here. You should have them in a little baggie that came in your box. That baggie will contain another baggie that has batteries in it. We just didn't want them touching end to end and then making a short circuit. I'll explain to you in a couple of minutes what a short circuit is. But you should have a little baggie that has all of this stuff. This is for decoration. And then these are the important parts to making it actually do the thing that it's going to do. Also, electrical tape, if you'd like to use that, you'll find it in your toolkit that you built last week. You're also going to need the cool glue gun, so go ahead and get that out, plug it in. Be careful with that, and be careful where you set it. We're going to talk about two different physical phenomena this week. So again, Making Saturdays Awesome, STEM-based program, science, technology, engineering, mathematics. The first one is the idea of friction. Friction is resistance to motion between one object and another as they move relative to one another. So both don't have to be in motion, but just the brush moving across the table, the tape sliding across the table, and you already have a pretty good idea of this. You know in your mind, if I just asked you to slide a gallon of milk across the countertop, you would know that that would be easier to do than to slide that same gallon of milk across a rug. And the reason is because a difference in the amount of friction between those things. The friction between the brush and the surface that it's moving across is a hindrance, but in our case, it's actually also going to help, because what we're going to wind up doing, we're going to vibrate the brush like this, and as it vibrates up like this, these are free to return to their original position. And so when it comes down and then it vibrates up like this, it vibrating up in this direction is going to put pressure on these and change their shape a little bit, bend around, and these will be released. So the progress forward and back is going to be slow, but its actual vibration is going to be very, very fast, much faster than you'll probably be able to see. But it's that back and forth motion as it creates stress on one side and for a moment creates stress on the other side. This, as it returns to normal, will propel it forward just a tiny bit. That's friction. The second thing that we're going to be talking about this week is circuits. Circuits and friction are useful to talk about together. They're very similar to one another in some important ways. To begin with, a circuit is a completed path for travel, just generally a completed path for travel. When we talk about circuits, we're usually talking about electrical circuits, and an electrical circuit is a completed path for travel for electrons. For this path to be completed, three things are necessary. The first is a power source, which is what the batteries are. The second is conductors of some sort. Many things are conductive at high enough energy levels. Anything can be conductive. For our purposes, our conductors are going to be wire and little tabs of metal on the back of our motor here. You also need a load for your circuit. You don't have to have a load for a circuit to be complete, but if you don't have a load, the electrons are so energetic and so willing to move around that if there's no load, if there's no work for them to do, then they'll move too fast and actually generate heat by doing so, to the point that they can melt or even light on fire. This is why we had the batteries in the extra little bag to protect them and you, and the mailman during shipping. The load for our purposes is going to be this DC motor. DC direct current as compared to AC alternating current. We'll cover the differences between these two more in later videos. For now though, we're going to be using batteries. Batteries supply DC current, and so we are going to use a DC motor to use up that current. And because there is a motor in the system taking electrical energy from the batteries, pipe through the conductors into the motor to do some kind of work that makes this a load, that it is taking electricity and doing some other work. All right, I think that is a fine explanation for now about all of the pieces that we're going to be using. Let's get to building. We're going to first take our brush, which is going to be the base of our autonomous robot that we're building today, also called a Brushbot. Make it whatever you like. It is a brush. So, Brushbot. Hopefully this is already plugged in. If it isn't, go ahead and do that because it takes a couple minutes to get it down. Anyway, we're gonna take the brush, and that's going to be the base. The first thing that we're going to mount up, I popped these in here for explanation earlier. I'm actually going to take them back out because you don't want those wires touching. That creates a short circuit. Were I to take these wires and just touch them together like that with batteries in there, it won't look like anything because the battery is not particularly powerful, but if you leave it for a few minutes, it can catch on fire, it can melt things, and that is super scary, not good, not what we want to do. So, while we're building this, we're not going to have the batteries in there, but we can pop them in and out, not a problem, because it's so easy to put them in and out. We're going to take them out, and then we're going to build with them. The front and back of your robot doesn't really matter. It will move in some direction when we're done, and which direction is for you to not only find out, but also make it do however it is that you would like. When we mount this motor, the direction of that spindle and which of these you decide, and also if you have all of these just like they are, or once you've started playing with it, if you change these at all, that can change the direction that it travels in like this, but it can also change which direction it wants to rotate as it goes. To begin with, we're going to take our battery compartment and our full glue gun, and we're going to just lock that down more or less in the center of your Brushbot. The closer to the center you can get it, the more balanced it is, so the more straightforward you can get it to go. So it's best to try to center this, right? We've thought about the nature of reality, space, and time, so our glue gun is one. Another thing is called dry fitting. When you're building anything, so you put it where you want it to go, and you're like, oh, okay, that's pretty good. But it also tells me about where I want the glue to be. You don't have to do this, but you can, which is you get it in its spot, more or less, and then you just make yourself some reference lines using the thing that you're going to put in the place to help you know precisely where to put stuff. Hopefully you can see these on the video, but you see that I'm roughing this in by hand. Not a huge deal. The glue's going to move around and squish as I put that down, so whatever. But I just want a vague idea. You don't have to glue the entire surface down. It'll be perfectly fine if you just put a line down the middle. But drop a line down that center line that I drew, set my glue gun carefully off to the side, dramatically drop my pencil, and then line that mark on the back of the battery compartment up, and the tab on the front of the battery compartment up. Pop this on and press it down a little bit. You'll see glue coming up through the holes in the bottom. Shouldn't be a big deal if you want. You can, after a second, blow on it. Now we have our battery compartment on top of our brush. Great! The next thing that we're going to mount up on our brush is going to be this little guy. This just holds our motor so that it is lifted up off the surface a little bit. And we're going to want it down at the other end. Make sure to move these out of the way. Because it's a brush, you can very nicely tuck them underneath, and they'll just, when you set it down, they'll just kind of stay. Another great reason to remove those batteries, because now the ends might be touching, I don't know, and if they were, the whole thing might be heating up because it is a short circuit. Right. Thank you for volunteering that information. All right. On this one, not as easy to get it centered, so do your best. Pop some glue down real close to the front here because we want the spindle of our DC motor to be able to stick out into space over it. We don't want it hitting once it has the cork mounted on it. We don't want that cork hitting onto our robot because that will mess it up, or it might make it really interesting. I don't know. Take some pictures, send them to us, that'd be cool maybe. Alright, So you put a little dollop of hot glue down, cool glue, if you will, and then you press your motor mount, this thing, down onto it. Should be pretty well held. If you need more glue, feel free. This might pop off as you're playing around with it. If it does, not a big deal. A human built it. A human can build it again. Don't worry about it. As you see, I'm out of glue. Luckily, I have my toolbox right here. Got all that. Cool. Now, this part can be a little finicky. This DC motor has 2 copper tabs. These are the reddish orange tabs here. They are both the color and the material copper. They are delicate. I encourage you to be very careful when you are winding your wires around these. They're easy to break off, and if you break them off, it is difficult to then get your wire to stick. It can be done, but it is difficult. So be careful with this. Mounting this up. The direction of electrons here is sometimes incredibly important. In this particular case, not very important. This will spin however it is that you wire this up, so don't worry too much about it. We're going to take one of the wires at a time, and we're going to very, very carefully feed it, preferably up from the bottom through the little hole on the tab. Without bending the tab, we want to bend that wire over onto itself. And then, again, very carefully, we want to bend it out at about a 90-degree angle there and twist it around. We don't want to twist the entire wire, we just want to twist the end around the wire. This is because, again, that copper tab on your DC motor is very delicate. A twist or 2 is fine. That will almost certainly hold. There are a couple of really good ways of making sure. One of them is solder. We might get into that later in this program, not for today's activity. Instead, what we're going to do is use your roll of electrical tape that you can find hopefully in your toolkit. At the very least, it should be in your box somewhere. I sent you one. So it's this black kind of plasticky tape. You find the end by just sliding your finger along. Electrical tape is pretty thick, so it's pretty easy to find wherever the end is. You can tear this stuff, but it's best not to because it stretches and then its stickiness is a little weird. It's much easier to just clip a tiny piece with the scissors, also included in your toolkit. You need a very small piece. We're not making a big connection here. I'm going to take and clip off a piece that is actually shorter than the width of the tape. That does make it difficult to handle, because then it will fall around and stick to things and you're going to lose it. That's right. You got a lot of it. Don't worry about it. I'm going to take this and I'm going to wrap that connection and then just continue to wrap it around a couple of times until I've used up the little tiny piece of tape that I've made. Again, it's very important that you don't twist the wire in relation to the DC motor or vice versa. You're just trying to get that tape to go around and hold that wire in place and together, and so that it won't slip off. It might slip off, who knows? If it does, a human made it, a human can make it better. Once you have one on, we're going to do the same project with the other wire, the other conductor. We are attaching 2 conductors right now. So you put it up through, you fold it over on itself and then out at like a 90-ish degree angle. And then you do a couple of wraps as best you can without twisting on that little copper tab any more than is absolutely necessary. Again, another tiny little slice of the electrical tape, which will instantly fall on the table. And if you are lucky, you'll be able to stick to your finger to pick it up. And if you are unlucky, it will stick instantly to the table, never be removed. I apologize to your parents. The way we're going to wrap this one is, again, we put it underneath and then kind of push up on it as best we can. You gotta be a little careful because you got that other wire in there. So you hold that out of the way with one of your 12 fingers, 37 fingers, however many you happen to have come pre-installed with. I have only the 10, it makes this slightly more difficult, but we pull that around, wrap it over, kind of pinch it. And again, you're not torquing, tweaking anything with a key on the connection there. Instead, you're just trying to get that battery wires to hold nicely. You can see that this red one is flopping around a lot. That's actually quite bad. And the reason is because even if the wire can't come off, if that hole opens up a little bit or it doesn't have good connection to the tab, it can make it very difficult for the electrons to flow through. So what we want is a really strong connection there. So I'm actually going to take another piece of tiny clip of my tape, which has instantly stuck to the table. While holding that out, I'm going to try to fold that tape onto itself to make sure that it holds the wire at a very particular place and doesn't wiggle around it. That has failed entirely, so let us continue and we'll just see if it works. Once you have that wired up, you just kind of press it into the motor mount. That is a completed circuit except for power source. We don't have the power source in because we were trying to get all of this set up, but now that we have it all set up, we will be able to install those batteries and probably get this to go. This particular battery compartment has a little switch on it. That switch completes the circuit. You can use this as an on and off switch for your project. Not all battery compartments will have that. This one does. So just lift it up so that this thing doesn't go jittering away as you install batteries. The spring in the compartment is where the flat end, that's the negative terminal of your battery, goes. And then the flat end is where the tiny, tiny little peg on your battery terminal will go. It's not about doing it right. It's about being able to hide the crimes. That is a basic rule of making, of woodworking, of cosplay. It doesn't matter if everything is duct taped and hot glued together. At the end of the day, what's important is that you know which parts can be and which parts can't be. I positioned this battery compartment, and then once I got it in a good spot, I decided to lay down some extra glue just to make sure that it's real secure. Okay, we're going to install the batteries the way that they go in the battery compartment. I'm sure you've installed batteries and things. Now you know a little bit more about why they are oriented the way that they are. And now we should be able to, when I flip this down, hear it start. Great. Perfect. That means that this circuit, even though this is far too loose, is going pretty well. The best way to get this to be able to go somewhere, because right now that center spindle is pretty well balanced, and we want it to be not as well balanced. Grab one of your forks. You have different sizes so that you can just try and see what happens. Doesn't matter which one you try first. I hope that you tried both of them. You can press the tip of the spindle into the fork. The fork is pretty soft, so you should be able to just press it in there without pre-drilling a hole. Now it'll slip on there. Great. Dramatically put the pencil away again. And now when I turn it on, you see not only is the Brushbot going to move, but it will move in a direction. It won't just be making sound. Ah! Nice. Okay. This is friction and electrical circuits, rotary motion, unstable rotary motion, all in action. As the batteries wind down, the movement of this is going to change. It'll slow down a little bit, and it's also not going to move in the same direction anymore because that vibration will be different. How far off center this thing is probably will increase, which will also change how it moves. These are things for you to ask questions about, to investigate on your own. The reason that we're doing all of this is so that we can look into how these things work and why they work the way that they do. And now we are going to move on to the last part of the build here, which is decorating this however you like. You have a couple of googly eyes, which you can put literally wherever you want. Googly eyes on the front of your robot implies that it is a predator. Googly eyes on the side implies that it is a much cuddlier prey animal. You'll see this in the world around you. You will notice that things that are hunted by other things tend to have their eyes out to the side so that they can cover with the eyes the greatest field of vision, whereas things that have to know about the exact movements and distance to an object have their eyes in the front of their head. This is a feature of evolution, fascinating stuff, totally unrelated to what we're talking about this week. I'm gonna put mine, just for being fair to all those. One will go on the side, one on the front, because it's my robot, I can do what I want. I made it, gets to do whatever I want it to be. Also, that's not even direction at times. Yeah. Oh, man. You'd be hunted to extinction so bad. Alright, I have a little pom-pom thing. I don't know what to do with these, so I'm just gonna glue them places. I think that'll be nice. Actually, because I know what the next thing is going to be, I'm gonna glue one right there, and I'm gonna glue another one right up here. You really don't have to do that. It's looking pretty dumb at this point. Don't feel it's necessary, but you can if you want to. All right, and the last part is these things. You can do antennas up here. You can do extra weird leg looking things like this if you want it to look like that. I kind of wanted to have a tail because I think that might look interesting. So I'm gonna just kind of double it up and then poke it down through here. And I think it was hot glue, actually. Yeah, it was a bit of a hairy process, but because I'm gonna have to hot glue it while this is through here. But drop some hot glue on there. You just kind of touch it into the bristle brushes, the brush bristles. That's what I meant to say. And move around a little bit because I got some hot glue on the table. If you get some of your cool glue on the table, don't do that. Do this on top of a piece of cardboard. Now, let's turn around and see what happens. Alright, the tail didn't look nearly as cool as I thought it did, and the reason it turned off is because not this, but that. You see that? That is a weakness in my design, in my build process. Find those in yours. They will tell you a lot about what is going on with the system, and also why things work and don't work, which is the fundamental reason that we're doing this. Thanks for watching another Making Saturdays Awesome video. I hope this was fun for you. It was definitely enjoyable for me. I will see you next week.